This is problem 8 from the Chapter 8 closure packet. Write an explicit equation for each of the following sequences. Explicit is not the recursive one, obviously, it's one or the other. Explicit is the one that most looks like an equation of a line and the equation of an exponential function. So we're still doing t of n because it's sequences, so both of our equations are going to start with t of n, not the t of n plus 1 stuff. So let's first figure out what kind of sequences we're dealing with. For part A, I have 100, 10, 1, then 0.1. This sequence is not adding or something each time. It is, most people would think it's dividing, but remember we don't want to say dividing, we say it's multiplying by a fraction instead. So this one you can do 10 divided by 100, and you're going to get 0.1, or 1/10 if you wanted to do it as a fraction. So this is multiplying by 0.1 every single time. So that means it's a geometric sequence. Just making sure you don't forget what those things are called. So for our geometric sequence, that looks really similar to AB to the x, that kind of equation. So we're going to say t of n, and then we need to find the starting value, which this is the first term. I want the 0 term, the number that would come before this. So I'm going to do 100 divided by 0.1, right? I'm going backwards. I want to find the opposite thing. So 100 divided by 0.1 is 1,000. And then in parentheses, my multiplier 0.1, oops, or you can write it as a fraction, and then raise to the n power. Because I have t of n here, I want to just be consistent with my variables, so that's why you put an n up there. And it's t of n because it's a sequence, which means you do not connect the points. Okay, so that's your explicit equation for part A. For part B, let's see what this pattern's doing. This one is getting smaller by a consistent amount every time. Let's say we're adding negative 50. Okay, you're kind of losing 50, but we like to say adding because that makes us think of the arithmetic sequence, okay? Which this equation, it's going to start with t of n again, but it looks really similar to mx plus b, y equals mx plus b, like a line, because this is consistently adding a constant amount, and in this case it's losing a constant amount of 50. So I'm going to need my slope first, or my common difference first, which is minus 50. Pencil is not liking doing this right now. So minus 50 and then an n, right? We want the same variable with it, not x. And then I need my starting value again, right? But I get this my starting value differently than in part A. So my starting value here, I'm going to get by, instead of subtracting 50, I'm going to add 50. And my pencil just ran out of lead, so let me just get a new pencil really quick. Okay, so we're going to add 50, so that would be positive 50, right? So I have plus 50 on the end. So my equation, if it's arithmetic, looks more like a line, y equals mx plus b format, and if it's geometric, it's kind of y equals ab to the x. However, we're talking about sequences, so that means you're going to use t of n, and if you were graphing these, you would not be able to connect the points. So this is the explicit equation for those sequences.